Hello everyone, let's get started. In last video, we discussed symmetry and skew symmetry matrix or tensor, right? So also we discussed one of the important properties for when matrix is antisymmetric or skew symmetric. In this video, I'm going to discuss some of the matrix algebra what you have studied earlier. Then I want to extend uh, that discussion to bring some of the advanced matrix algebra that we need in our continuum mechanics, right? Okay, let me go to next page. Okay, so in this video, first I am going to discuss minor of the matrix of a matrix. Okay, so let me take one matrix, right? Matrix A. Let's take one um, example. Let me take, let's see from my this one. Okay, 3, 4, minus 1, then 2, 0, 7, and 1, minus 3, minus 2. Okay, right. In the matrix, okay, we denote the column index, the row index as I. So this row is I equal 1. Okay, I will write it in a different color. Let me bring this one here. I will write it in a different color, right? Okay. So this is I equal 1, I equal 2, I equal 3. Then here, the column 1, j equal 1, j equal 2, j equal 3. Okay. So for example, let's say the element of A 2, 3 is actually the 7, right? This is our general matrix notation. What we define as a minor, for example, let's say minor of 7, element 7, right? What we define minus 1 to the power I plus j into that element, right? That element is, that means aij, right? So this is actually minor of an element, right? So for example, here minus 1, I is 2, j is 3, right? I is 2, j is 3, this is 7, right? Then minus 1 to the power 5 is minus 1 into 7 minus 7. Okay. This is the minor. Okay. This we define as a minor of a matrix, right? This part. Similarly, for example, let's say minor of number minus 2. So that means minus 1, I plus j, both are 3, right? 3 plus 3 into minus 2. So that means minus 2, right? Okay. This minus 1 to the power I plus j, this we called as cofactor sign. Okay. So if you consider one 3 by 3 matrix, the cofactor sign, it will be like this, right? So that means the first one is plus because I plus 1, 2, right? Second one is minus, third one is plus, right? So you can consider that alternative sign, right? So for example, if it is plus, this is minus, this is plus. It is minus, this is plus, minus, minus, plus, right? So this is the cofactor sign of any 3 by 3 matrix. Okay. Right. So this is first thing, right? So for example, if we want to write the entire minor of the matrix, minor of matrix A, so with sign, you can write it, right? Okay. You can write it. Right. This is my 3 minus 4, right? Another one is plus, therefore that will be minus 1, right? Second one is minus, right? So third one minus, therefore minus 2, 0, minus 7, right? So here 1 plus 3, because minus into minus plus, right? So minus 2. So this is the minor matrix of the given matrix, right? Okay, so this is not a difficult things. Sometime you might have forgotten, right? So that's what I just refreshed the minor of a matrix, right? Okay. The second one we are going to discuss here, it is cofactor matrix. Cofactor matrix. Okay, so this we represent as C, cofactor matrix. So what we define as a cofactor matrix, right? Cofactor matrix. So let's say cofactor element, right? Cij. It is minus 1 to the power I plus 1. That means minor I plus j, right? Into next one is the cofactor. So that means the particular element aij, the minor, into the determinant, right? Determinant of the cofactor part, right? So that means determinant of, I will write Cij. So this is actually the cofactor matrix, right? So what is this? So let me take the same example, right? Let me bring the same example here. Okay, right. Okay, then you have to remember the sign, right? That means I will write, uh, okay, sign also I'll bring for your information, right? Okay, this is the sign, right? Okay. Now, let's say I'm going to write the cofactor. That means cofactor matrix C11. Okay, the first element of cofactor. So what I have to do? First, minus 1 I plus j, that is actually the sign, right? That sign is plus. Then write 3, right? The element. Then what you have to do? You have to cover this one, right? Our usual determinant. How we calculate the determinant? Cover vertical and horizontal here. Then the balance part. What is the balance part? Determinant, right? 0, 7, minus 3, minus 2, right? Okay. So this one now 3 into this is 0. 0 minus minus 21, that means plus 21, right? So that means uh yeah, plus 21, right? Okay. Sorry, not this one, right? So not aij, just only this one, right? Yeah, determinant only we need this one. This we are considering the uh, cofactor matrix, right? Sorry, this aij is not there, right? The answer is now 21, right? Okay, 21 is the answer. Similarly, let's say you are going to calculate C12. The first, okay, this is determinant. Okay, here the second, the cofactor sign, right? Minus. Minus is a cofactor sign. Then second one, right? So now what you will do? You will take, you will take here, right? So this column, this row, right? The balance, what is balance? 2, 7, 1, minus 1, right? So that will be minus, this is minus 2, minus 7, right? So that means 9. Okay, minus 2, minus 7, right? Okay, everything is correct, right? Let me check. 2, 7, sorry, this is minus 2, right? Okay, 2, 7, 1, minus 2, right? Minus 4, minus 7, right? So that means this will be 11 now, right? 11. Okay. So let me calculate one more things, right? Then finally we can write the matrix, right? C1, 3 now, right? C1, 3, the third element, right? Cofactor sign is plus. Now you will connect, this one, right? This row, this column, right? 2, so this time let me write it carefully, right? 2, 0, 1, minus 3. So that means 0, sorry, minus 6, minus 0, right? That means minus 6. Okay. Then finally, you can write total cofactor matrix the similar way, right? So for example, here, for when you take 2, just cover these 2, this 4 will be there, right? So like that, you can get the total cofactor matrix. So in my case, I already calculated this one. Let me write the answer 21, 11, minus 6, right? This first row I have calculated. Second row you can check, right? 11, minus 5, 13, 28, minus 23, and minus 8, right? Okay. So this will be the answer for this cofactor matrix, right? Okay. So again, we discuss here the cofactor matrix, right? Cofactor matrix is actually the extension of the minor, right? Okay. Right. So now by combining both, we are calculating the determinant, right? Okay. Right. So if you want to calculate the determinant, okay, let me calculate the determinant also, right? Determinant of, okay, we will calculate later. Before that, let's discuss uh, another thing, third part, right? Third part, inverse of a matrix, right? How do we calculate inverse of the matrix? There are many methods, right? Because 3 by 3 matrix only we considered here, most of the cases. I cannot say only, most of the cases we consider 3 by 3 matrix. So therefore, inverse of the matrix we define like this, right? That means adjoint matrix, adjoint matrix of A, right? Adjoint matrix over determinant of A. Okay, so this we define as inverse matrix, right? What is actually adjoint matrix? Adjoint matrix is the transpose of cofactor matrix, right? Transpose of cofactor matrix. Okay, for example, in our previous case, right? Cofactor matrix we calculated, right? So let me bring that cofactor matrix. So this is the cofactor matrix. Okay. Then you need adjoint matrix. So that is transpose of cofactor matrix. That means you can write transpose, right? 21, 11, minus 6, right? row become column now, right? 11 minus 5, 13. So this is 28 minus 23 minus 8. Okay. So also you can calculate determinant of A, right? Determinant of A, that is you can calculate simply. That's already we discussed. Most of the case, right? So in my case, I calculated already that was 130, right? That will be 130. Then you can find inverse of the matrix, right? So that is 1 over 113, this matrix, right? Okay. So this is our inverse. What happened? Okay. So this is our A inverse, right? Okay. Right. Right. So you can simplify, right? If you want, you can simplify with decimal, right? Okay. The fourth one we are going to discuss, the cofactor matrix. One of the application is we can find the inverse matrix, right? The fourth one, what we are going to discuss, determinant of, that means differentiation of matrix I with respect, I will write first the matrix notation, determinant of A with respect to determinant of A. This will be, 1, right? That means identity matrix, right? So if you write it in a index notation, D, you cannot write uh, you cannot write like this, right? You cannot write ij, right? Because now this is the matrix, right? If I write it aij, no free index here, right? Because all are repeated index, right? So therefore, I have to write it one free index, right? One can be repeated index because I need two free index, right? So therefore, I will write one thing is ik. Okay, so what is this one? Delta. Okay, so when you write here always differentiation, write the denominator index first, then numerator index second, right? Delta, no problem. You can, if even though if you write it kj, delta kjk and delta kj is same because it is identity matrix, right? But we discuss this one in our next lectures. The differentiation we are going to discuss. In that case, you must follow this one, right? The first one, denominator index. So second one, numerator index, right? Okay, right. So you can think this way, right? Here you can see when j and k are equal, you will get 1, right? J and k are different, you'll get 0, right? Differentiation is 0, right? So that is the fourth one. Okay. The fifth one, okay. Let's say determinant of A, we will write in terms of the cofactor matrix. So for example, let's say the determinant A. Determinant A, that means, okay, this one, right? Let's say A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, right. If you want to calculate, I'll take the first row, right? First, you will take A11, then you cover the row and column. You will calculate this one with the cofactor sign, right? It's actually the first element of the cofactor matrix, right? Okay. Second one plus second element A12, cofactor sign now minus, right? But that is we include in the cofactor matrix, right? So here you will get C12, right? Okay. So you know the matrix multiplication, right? C12 and this will be, I can write C21, right? Okay, C21. Because metric multiplication, the first, that means second digit of the first matrix, first digit of the second matrix must be same, right? I will write according to the this one, right? Okay, plus the third one, A13 C31, right? Okay, right. So you understand now why we have written now adjoint matrix here, transpose, right? Because of this one, right? We have to switch the sign here. Okay. Now, if you want to write this one in index notation, how can you write that? That means repeated index, right? 3, 3, 2, 2, 1, 1, right? So I will write that one first. I will write this one K, K, right? Then another one is a pre-index, right? That means I, okay, I 1, 1, right? So I can write, it should be the this one, right? It should be, uh, it should be the what you call it? It should be scalar, right? So therefore all must be uh, the repeated index, right? The MSCKI. Okay, right. Okay, so this is the determinant of the matrix, right? Okay. Right. So now I am going to the sixth one, right? The last part what we are going to discuss in this video. Here, what I am going to discuss here, in continuum mechanics, the following differentiation, that means determinant of A with respect, differentiation of determinant A with respect to the matrix. So we studied something called deformation gradient. Also, we study the rate of change of deformation gradient. That means time derivative and volume change, those things, right? For that case, this determinant is very important, right? This differentiation is very important. How can we calculate this differentiation? For this one only, I'm going to use index notation. For this one only, we discussed already how to write determinant of A in terms of index notation, right? What is that? CIK, CKI, right? Because this is the this is a scalar, right? There should be no any free index. That's what I also repeated index, K also repeated index, right? AIK, CKI, right? Okay, I'll put bracket with respect to AIJ. Okay, A is AIJ. Right. So now, okay. Now consider this differentiation, right? For example, in previous case, let's say if you consider A11, this is our differentiation, right? With respect to, I am going to differentiate the determinant with respect to A11, right? When I take A11, when I differentiate, this is the the determinant, right? So that means A11 is here. The balance part C11, right? So that means this C11, it's independent with A11 because within this cofactor matrix, you know what is this cofactor matrix, right? So that means for a fx case, the plus is a cofactor sign. This is the cofactor matrix, right? A22, A23, A32, A33, right? So this one, you know, independent with A11, right? So therefore, when you differentiate with respect to one coefficient, the cofactor matrix, it is independent with that coefficient. That is just a constant, right? You can take it out. CKI. So here you will get AIK, differentiation of AIK with respect to differentiation of AIJ. This is just now we discuss our fourth one, right? CKI. So this is identity matrix, right? So what you have to do, the common one remove, write this one, right? When you write the denominator one, you have to write first, right? J, then numerator. Okay. Right. So now you can apply the cofactor, that means uh, what is that? The properties of delta, Kronecker delta, right? So what is that? The common one remove and replace with the balance one, right? C, J, I. So what is this actually? Your cofactor matrix, right? So that means differentiation of determinant with respect to matrix itself. This is actually the cofactor matrix. Okay, we discuss the inverse of a matrix. It is actually adjoint matrix. That means transpose of cofactor matrix over determinant of A, right? Okay, so now C transpose is equal determinant of A into A inverse, right? So that means I will write determinant of A into A inverse, right? So C is actually, if I take transpose, determinant of A is a scalar, that is just a number, you will get the same. Transpose of inverse, we can write like this, right? Okay, so this is actually inverse transpose, right? So we will write like this, right? Okay. Right. So therefore now finally the different determinant of, that means differentiation of determinant A with respect to the matrix itself is this one, right? Determinant of A and A transpose of A inverse, right? Okay. Yes. So this is very, very important findings. We will use a lot when we derive constitutive model, especially for plasticity, everything, right? Okay, I think this is the right time to stop this video. Uh, so as usual, of my the wrapping up sentence, right? Please share, uh, like and share, and subscribe if you do not subscribe already. If you haven't subscribed our channel already, please subscribe. Then also please share among your circle. Then it will help us to reach international audience, right? Okay. Then see you on next video.